Hey Calc AB students, welcome to a lesson on how to approach the Unit 3 free response question, Part A. Let's start with the information that's provided first. Clearly we have a table, but right below that it says the table above gives values of a twice differentiable function f and its first derivative f prime for selected values of x. Part of what this sentence is saying is if you need to plug in values for f or f prime, use this table. More specifically, it says you could only plug in -3, 0, 3, and 6. This sentence also tells us that the function f is twice differentiable. That actually means quite a bit. It means the function f is continuous because differentiability implies continuity. It means f prime is defined, so therefore we could take the first derivative of f. It also means that f double prime is defined. We could take the second derivative of f. The last bit of information says, let g be the function defined by g of x equals f of x squared minus x. This means two things. One, it's a composition function. G is defined by f of some function of x. So if we take the derivative of g, then we're using the chain rule. Two, because g is dependent on f, which is a twice differentiable function, then g is also a differentiable function, which again means that g is continuous. Now that we know that, we could take on the first part of this question. What is the value of g prime of 3? Notice that 1 point is given for finding g prime of x, and 1 point is given for the answer, which is not information that you would usually know. Let me show you how to do that so you could try it on your own. Suppose y is equal to f of u of x. Basically, I'm saying y is equal to g and u is equal to x squared minus x. Therefore, y prime, the derivative of y, is equal to the derivative of f, the derivative of the outside, leaving the inside the same. So f prime of u times the derivative of the inside, which is du dx, or u prime of x. So y prime equals f prime of u times u prime of x. That's called the symbolic derivative of y and can be applied to the first part of this question when finding g prime of x. To find the actual answer to this question, you simply plug in 3 everywhere you see an x and then use the table above. You can pause now to try that, or finish the video first. The second part of this question tells us that g double prime of 0 is -1 and asks us to find the value of f double prime of 0. Notice that 2 points are given for finding g double prime of x and 1 point for the answer. Since we're being asked about f double prime of 0, there are only two things to consider: the table or the relationship between g and f. Since the table doesn't list any values for f double prime, we can only use the symbolic relationship. Let's pick up where we left off. Y prime equals f prime of u times u prime of x. We need to find y double prime because that will result in an f double prime on the right side of the equation. To do that, we use the product rule and the chain rule. Y double prime equals left d right plus right d left. Notice that the chain rule applies again, and we end up with an f double prime on the right side of the equation. If you apply this process to part 2 and plug in what you know, you'll be able to find out what you don't know, which is f double prime of 0. You can pause now to try it or keep watching. Part 3 of this question is an intermediate value theorem problem. Is there an x value, c, on the interval 0 to 3 such that g of c is 5? Notice 1 point for explaining why g is continuous and 1 point for the justification. The intermediate value theorem says that if a function is continuous from a to b, then that function takes on every value from f of a to f of b. To apply the theorem, we need to show that the function is continuous and then identify the two y values that we're comparing. At this point, you should be able to explain why g is continuous. We covered that concept at the beginning of this video. The justification for the IVT flows from the comparison of f of b, f of a, and f of c, whatever number that is. If f of c is in between f of a and f of b, then the answer is yes. For part 3 here, you're comparing g of 0, g of 3, and g of c, which we already know is 5. Try it out then. See if you could explain why g is continuous, then evaluate g of 0 and g of 3 using the equation and the table. Pause now. Okay, we made it to part 4, the very last part. It introduces a new function h and defines its derivative to be 4e to the cosine x. It's looking for an x value in the interval -3 to 0, and that x value is where the instantaneous rate of change of h, which is h prime, is equal to the average rate of change of f. There's 1 point for the average rate of change and 1 point for the answer. Recall that the average rate of change of a function is simply slope. So the average rate of change of f from a to b is f of b minus f of a divided by b minus a. The difference in the y values divided by the difference in the x values. So that's what you'll calculate first and get a point for. The second point is for finding when that average rate of change is equal to h prime. We need the graphing calculator for that. And the graphing calculator needs to be in radian mode. Enter h prime in y1 and enter the average rate of change of f in y2. Then find the x value in which y1 equals y2. Try it out, or just listen to this last thought. In general, this question should feel like a medium level of difficulty question, but it can seem more difficult because it expects you to know and apply some major concepts. Those include the chain rule for part 1, the product rule for part 2, differentiability, continuity, and the intermediate value theorem for part 3, and the average rate of change of a function for part 4. Now that we broke it down, hopefully it seems like an appropriate level of difficulty. That's all for now. Thanks for watching and listening.